Welcome back everyone. In today's exciting episode, we're going to be talking about JavaScript tooling again. In the previous episode, we talked about Vite and how all the different parts of it work together. I thought over the next little while, I'd incrementally build out a very small version of each one of these tools just to give you an idea of how they actually work under the hood. I decided to start with hot module reload today for a few reasons. Namely, it's kind of one of the most exciting parts of the JavaScript tooling system, at least to me. The fact you can magically or almost magically update code on the fly is really cool. And when I first started off with JavaScript, this was something that really kind of blew my mind. I felt almost magical. Like most magic tricks, it's just smoke and mirrors, and all those tricks become very simple once you understand how they work, and that is going to be the goal of today. We are back with another complex diagram, and this is going to help us work through and understand all the different parts of hot module reload. There's two primary components. Over here on the left, we have the server, which we're going to talk about, and then after that, we're going to talk about the client, and then the glue in between that wires everything up. I'll give you a quick demo of our application, and then we're going to work through the server, the client, and then the dev server component, which kind of wires everything together. Again, if you like this kind of content, I am slowly working on a book about it. You can go ahead and join the mailing list to get some updates. So here's what we are going to be building. Just going to head over here and refresh the page. Apparently my server's not running. I think it's on a different port. Okay, so we have a very simple application here. We have the time that it was rendered, 12:01 and 49 seconds, and we have a component that confesses its ID. The goal is going to be to get this component to hot module reload without changing anything else. Let me go ahead and give you a quick demo right now. Just going to make this window a tiny bit smaller so you can see what is going on, and I'll give you a tour of the application. The top level is going to be inside of index.html. We're just going to import main.js. Heading over to main, we're going to import mount and mount our component. This is sort of like a React component. It's just going to be a function. We create an element selector right here. We're then going to go ahead and render the time. That's what you're seeing over here. And then we're going to go and update the text and append a new child. And this is what we're going to hot module reload. You can see our hot module API right here. We'll talk a little bit about why we need to write this in a moment. But heading down here, we see our component, create a div, create a child, randomly create an ID, and go ahead and render it. With a bit of luck, if I save this, you can see the ID is getting updated. The rest of the DOM is not updating, and that's because we have hot module reload enabled and everything is working correctly. And the goal is going to be building out the server and the client component for this and explaining how it all works under the hood. Again, we're going to have it in 3 phases all in one video, so this is going to be fairly long. We're going to go ahead immediately and get started with our server component and write everything from scratch so you understand exactly how it all works under the hood. Let's go ahead and get started with the server component. We're going to start off kind of on this side by just implementing a server that serves up all our content. We're then going to augment that, adding some hot module reload middleware to augment the module, which is going to eventually allow us to implement our HMR API on both the server and the client. Let's get started. For now, we have absolutely nothing, so let's head over to our editor and start coding this out. We have got a few imports. If you haven't seen this before, I'm using the Node protocol. This is just going to make sure we're using the ones from the standard library as opposed to some we might have installed from NPM. We're also going to be using a few NPM modules, Express for the server just because it's simple and well known. We're going to be using a library called Chokidar. This is very common in dev tools, and this is basically how you do file system watching, so we can respond when the file is changed, added, or deleted. And we're going to be using the WebSocket module as well. The first thing we're going to do is just create a very simple static server to serve our content. So I'm going to go ahead and say const app, and that is going to be equal to a new Express server. We're also going to create a HTTP server, so I'm just going to call this one server and say http.server, and this does allow us to pass in a handler. I'm going to pass in app, which is a valid handler. Next thing we're going to do is simply start the server, so we're going to say server.listen. We're going to listen on port 8080, and of course we're just going to have a little log just to let us know it's working, so listening on port 8080, and save it off. If we did everything correctly, we should be able to at least start up our server at this point, head back to the browser and verify that is the case. We're currently not handling any of our static assets, so let's go ahead and do that as well. I'm just going to go ahead and say app.use. We're going to use the Express static middleware. We need to pass a path, which is just going to be the current directory. If we did everything correctly, we should now be able to serve up our application. I'm not going to be using any anything like nodemon to watch my server file. I like to do everything with the simple tools when I'm building dev tools, just because there's already enough complexity going on, and minimizing the complexity makes it much easier to debug. If we now refresh the page, everything is now working. We have no hot module reload, we're simply serving our assets, but that's already a good start. So the next thing we're going to do is implement a very simple HMR middleware. What this is basically going to do is give us an entry point to augment our JS modules, which is going to let us inject our HMR client, and this is going to give us more fine-grained control over our modules to change them how we see fit. So let's do that. The first thing we're going to do is create a new handler, so I'm just going to go ahead and say const HMR middleware. I'm not using TypeScript right now, again, just to keep things simple, so I'm just going to use a type annotation. We can say express.handler, and this is going to give us some minimal completion. The handler is going to have 3 arguments: request, response, and next. And we only want to do this if we're using a JS module. If it's anything else, we're just going to go ahead and return immediately. So I'm going to say if request.url.ends with, and if this is going to end with anything other than JS, we're just going to go ahead and call next. So we can just say return next. Finally, if it is JS, we're going to load the file and do whatever we like. Just to verify this is working, let's go ahead and try it out. The first thing we need to do is make sure we apply the middleware by saying app.use and pass in HMR middleware. Head back to our browser, just going to restart this one more time, and we are going to get an error here, of course. And the problem is we are not handling JavaScript assets, so it's just going to wait and load forever. Let's go ahead and fix this up with JavaScript. So the first thing we need to do is load up our source file. I'm going to create a new variable called content here, and we're just going to await. We're going to need to make this async as well if we'd like to be able to await for that. So let's just fix that one up as well by saying async. And we're going to say read file and just read our JavaScript file. That's easy enough to do by just saying path.join. We use path.join to make this cross-platform. We're going to look in the current process.cwd as our current reading directory. Then we're just going to pass in request.url. And for good measure, we're going to make sure we load it correctly using UTF-8. Finally, we can go ahead and simply return this by saying res.send and send our content. The final thing we're going to do is make sure we set the headers correctly. I can just say res.type and pass in .js. If we don't, it's not going to load our module correctly. If we did everything correctly here, this should hopefully be working. Let's go ahead and restart our server one more time, head back to the browser, and everything is now loaded correctly. Head over to our network tab, we see these are going to get the correct types. We can see it's application JavaScript. If we didn't do this over here and say res.type is JS, this would be application text and we get a very cryptic error. So it is very important to make sure when you're writing your own middleware to handle assets, to make sure you set the type correctly. The next thing we're going to do is augment our module and add in our HMR client. We haven't actually got one of those yet, so I'm just going to go ahead and create something here to give you a basic example. I'm going to say hello from client. We're also going to create a function called HMR client. It's going to take the module as the first argument, which we'll talk about very soon. Let's go ahead and just try this one out first, and then we're going to come back and implement HMR client. If I head back to the server now, what we need to do is make sure we're loading the client as well. So we're going to do exactly the same thing here and just go ahead and load the client. Finally, we're going to concatenate these files together. Let's go ahead and just mutate content. I think this is going to be perfectly fine. We're going to first add in the client by saying client. We're then going to go ahead and add in the content. If we did everything correctly, we're going to concatenate these together and then return the result. Let's try this out and see what happens. Kill my server again, head back to the browser and refresh. We are getting an error. Let's see if we can figure out what the problem might be. It is not happy about that at all. If I head back and refresh the page again, the whole thing is broken, so we did make a mistake. Let's see, I think we're not loading the client correctly, and that would be the case. And of course, the problem is I forgot the extension over here. Let's fix that one up, and hopefully, with a bit of luck, this is now going to work correctly. Restart our server, head back, and everything is now working correctly, and we are saying hello from client. If we head over to the network tab, we can see the code we are serving is not the code we wrote. It's got this additional code up here as well. This is very common when you're writing dev tools and HMR clients. If you have a look at the code that is served up when you use Vite, you'll see that what you see in the response is completely different from the code you wrote in your editor. And this is completely normal. We're going to just continue on with this for now. There are ways to fix this up and use source maps to make it a bit more understandable. That's another topic for another video. Either way, the next thing we need to do before we continue on is go ahead and just call that function and see what happens. We have HMR client function. It's going to take the module as the very first argument, and then we're going to talk a little bit about what you actually receive as the very first argument. Just as a reminder, if we head back to the client, this is the HMR client. What I'm going to do is log the module for now, and we're going to extend this in just a moment. Heading back to the server now, we're going to say HMR client. Again, this is defined inside of this client, so we do have access to it. And we're going to pass in import.meta. This is going to give us information about the current module, and this is going to be instrumental in allowing us to implement hot module reload. Save this off and give it a try and see what happens now. Head back to our browser one more time, refresh the page, and we are going to get different console logs. Right now we're receiving fairly minimal information, but it is very useful. Critically, we have access to the URL, so we know where this module is being served from. This is going to serve as an identifier later on when we want to make sure we're only uploading or updating the modules where we save the file and change something. Just as a quick recap before we go any further, we've mainly focused on the server at this point. We've created a very simple server. We have over here the HMR client. We're passing in import meta. That's the code we just wrote just then. And then we're going to respond and serve these back up to the client. The next thing we need to do is talk a little bit about what the client is going to do and import.meta.accept. At this point, we're going to move from the server over to the client. So let's head over to the client file and start working through our hot module implementation. We're now going to shift our attention away from the server onto the client. This is the exciting part where we actually implement hot module reload. We're going to be working in this area, import.meta.accept, which is what holds the front end and the back end together and makes hot module reload work. This accept callback is really the critical part. This is what tells your function or your module how to update. There are lots of examples of this. For example, with React, there is the React fast refresh library, and that tells React components how they need to update their state. We're going to implement our own very simple version, and then we're going to wire it up using a hot module class. Just to clarify what I'm talking about, this here is how we are going to update our module. The first thing you always do is see if hot actually exists. This tells us we're in a development environment that does have hot module reload enabled. We're then going to have an accept callback, and this is something common across all hot module reload frameworks, and it's going to take an argument of the first module as a callback. Whenever this is updated, we're going to call this callback with the new module as the first argument, and then we can go ahead and update our module how we see fit. This is going to be different for things like React and Vue. In our example, we're simply going to do a console log. We're then going to find our element and replace it with a new one. And this is going to wipe out the old one and create a new one with a unique ID. For something like React and Vue, you'd have to do things like create a new component, but maintain the state. That's something that's a bit more complex and not something we're going to be discussing here, but something we will talk about in more detail in my book. Either way, let's go ahead and start implementing this. The first thing we're going to do is create a class to keep track of everything called hot module. It's going to take a constructor which is going to receive file. What this is going to be is a reference to the module. In this case, it is going to be this last part here, just a reference to the name of the file. This is going to be very useful later on when we go to update these incrementally based on which file was changed. So the first thing we can do is go ahead and just create a new hot module. And we're going to pass in the correct path. In this case, we're going to pass in the URL. We can create this by saying a new variable, a new URL, and then we're just going to pass in mod.url. And inside of here, we can say the path name. This is just going to give us the last part. Before we go any further, we're going to do a console log just to make sure everything is working as expected. And we're then going to say this.file is equal to file. Let's save this off and give it a try. Everything is working correctly. We have 3 hot modules, each with a different file, which is really good to see. The next thing we're going to do is go ahead and make sure we're actually entering in this conditional over here. So in here. This means we need to make sure hot actually exists, and currently it does not. Luckily, we can just go and say import.meta.hot and assign hot to that. If we now head back to our browser, that is working correctly, but we are getting an error. Accept is not a function. This is entirely expected. We have accept here, and accept is not a function, so let's go ahead and define that one. It's going to take a single argument, which is going to be the callback, and this is going to be executed when the module needs to be updated. We need to save a reference to that one as well, so I'm just going to say this.cb is equal to cb. Finally, if we go ahead and save this off, head back to our browser, we are no longer getting an error. We're only seeing one log, and this makes perfect sense. Because child implements hot module reload, we are going to see this log here. But if we have a look at something like app, we can see HMR is not enabled here. Ultimately, what we would like to do is abstract this into a separate module and inject this to all of our components to give everything hot module reload out of the box. That's an improvement we can make later on. Either way, this is now working, and the next thing we need to do is make sure we're getting inside of here and then calling accept with the new module to update it. We're going to do this in another function called handle accept. What we need to do now is implement hot module reload, and this is where the magic occurs. The first time we loaded the application, we simply loaded all the modules and execute them all. That's what happens when you load a JavaScript module, it is executed immediately. What we're now going to do is reload the module. That's going to be this line here. The main difference is we're also going to add an additional parameter, tier is equal to date now. And all this is going to do is ensure we're not using the cached module, we're going to get a brand new version. And that's going to include any changes which we can use to hot module reload. So let's go ahead and see how you can do that. All you need to do is import the new module and then execute the accept callback. So we can go ahead and say import this.file. Remember, this is a reference to our file, so /source/app or something like that. Once that's been imported, it is a promise, and the callback is going to have the new module. We've now got the new module, which is really good. We need that over here inside of our child. All we need to do is go ahead and call accept. So we can say this.cb. This is going to be that accept callback, which I talked about just then. And we're going to pass the new module as the very first argument. Finally, we need to add that t parameter just to make sure we're not using the cached version. So I can go ahead and say t is equal to and pass in date.now. Let's find the correct symbol, date.now. With a bit of luck, if we call handle accept, we're going to import the file with the parameter to ensure we get the newest version. We're then going to get the new module and call this.callback. As a reminder, this callback here is this one over here. And that's going to have the new module. If new module exists, just a bit of defensive programming, we're going to go ahead and execute our hot module reload. Let's go ahead and give this a try. We need some way to execute handle accept. I might just go ahead and do a set timeout here to see if it works. So we're going to say set timeout, and after, let's say 1000 milliseconds, we're going to say let's call handle accept. Save it off, head back to the browser and see what happens. If we refresh the page, that actually did work. We can see all three of these are updating, which is really not what you would expect. What we're expecting is just one of these to update. They are getting an error here as well. And that's because we're just trying to call a callback which doesn't exist for two of our three modules. That is an easy fix, so let's go ahead and make it. We're going to do a conditional here and just say if the callback does not exist, we're simply going to return early. Let's try again one more time and see what happens. That is updating correctly. Just to confirm the whole thing is not refreshing, let's go ahead and take a look inside of here. Unfortunately, that is going to go ahead and close. What we can do is use set interval instead, and this is going to update every 1000 milliseconds, and that is working correctly. We are hot module reloading without updating any other elements. And that's actually quite a small amount of code. Just to clarify, the trick is to import again with a parameter to avoid the cached version, and then ensure we're importing or implementing hot module reload on the other end inside of our module. This is of course far from complete. We're updating this every 1000 milliseconds, and what we really want to do is do this incrementally on every single file change. So let's head back to our diagram and see if we can continue on back to our server and implement that. If you made it this far, congratulations on sticking around. We are almost finished. We've got a little bit of work to do, but it's going to set ourselves up for success in the long run. So far, we created a very simple server and a simple HMR client. The final part is going to be implementing the dev server part, which is going to be a WebSocket telling our client when to update, and a file watcher which monitors our files for changes. Finally, we'll trigger a HMR update by using the WebSocket and sending a payload to the front end, triggering the hot module reload. We've got a little bit of work to do here, but it's going to set ourselves up for success. Remember, we're not just building a hot module reload, we're going to be building an entire toolchain eventually, and this is just one small part of it. The more work we do now, the easier things will be later on. I forgot to show this before, but you can come over here and see all the imports triggering every second, which is pretty cool. We have our hot module reload, but it's not something we need right now, so I'm going to go ahead and delete that. And we're going to head back to our server and implement the server side now. Just to clarify, we need two things, a file watcher and our WebSockets. And if we head over to the diagram, that's going to be this part here, the file watcher, and the WebSocket, which is going to send the request to the front end. We're going to start off with the file watcher, and that is going to be using Chokidar. Let's just go ahead and create a new watcher. And we're going to watch everything inside of source ending in JS just to get something working for now. The next thing we're going to do is respond to this by saying watcher.on. And every time a file is changed, we're going to grab a reference to the file and just do a console log to make sure everything is working. The next thing we're going to do is create a new WebSocket, and I'm going to run it on the same port as my server, which is 8080. First thing we can do is go ahead and create a new WebSocket server by saying new WebSocket server, and this gives us an option to pass in a server handler, exactly what I am going to do. So when you have a WebSocket server, many clients can connect. Every time one connects, you get a reference to that socket. We're going to save a reference to that socket, and then we're going to use it inside of the watcher and pipe a new event to each of the clients. In our case, there's only going to be one client. We're going to have one socket which monitors all of our modules, but you could probably implement this in different ways. Maybe there's a reason you want multiple sockets or something like that. Either way, we're going to go ahead and create a new socket here. It's going to be a variable with a type of, let's just say, WebSocket. And then when we've connected, we're going to grab a reference to that. The way you do it is like this, by saying WebSocket.on connection. The first argument is going to be the socket, so we're just going to go ahead and grab that one and say socket is equal to underscore socket. I'm also going to do a console log and just say connected to make sure everything is working correctly. Finally, we need to connect to this to see it working. So let's head over to our client and define a new WebSocket connection. Again, I only want one WebSocket connection per for all of our modules. So let's go ahead and create a new variable. I'm just going to call this one WebSocket, and it is going to be globally available. If this doesn't exist, so on the very first render, we're going to go ahead and create it. I can say const ws is equal to new window.websocket. That is going to be ws, and it's going to be on the same port, which is localhost 8080. The next thing we're going to do is connect to it and listen for messages. So I can say ws.addEventListener, and we're going to listen for messages. That is going to be in here. And there's a whole bunch of information available for this. I happen to know the one I want is called data, and it is going to be a serialized JSON object. So I'm going to say json.pass message.data, and we are going to go ahead and do a console log just so we have something to look at. Finally, we're going to assign that variable. So window.ws is going to be equal to ws. And we did everything correctly. This should actually be connecting, and we should see at least a console log on our server. First thing we're going to need to do is restart our server, head back to our browser and refresh the page. And we are not seeing anything here, which is expected. But if we head over to our terminal, we are seeing connected because we successfully connected to our WebSocket. Just to make sure our file watcher is working as well, I'm going to head over to child and save that one off. If we now head back to our terminal, we are getting a log, and that is indicating the file watcher is working correctly. So the next thing we need to do is send the message from our WebSocket over to our client. The only relevant information we really need to know is which file was changed, but I'm also going to include a type of file changed just to give ourselves extensibility in the future if we'd like to let people write plugins for our toolchain. So let's head over to the server and do that. Whenever a file changes, I'm going to create a new payload. Again, that's going to be a JSON object. The type is going to be, let's just say, file changed for now, and we're going to pass in the file as well. This is going to have a trailing slash just because that's what I'm using as my convention. We're going to pass in the file. This is going to be very useful in just a moment, and I'm going to show you why. But before that, I'm just going to go ahead and say socket.send and send my payload. We've now got another problem to solve. This is going to be globally available, and we don't actually know which file or which module we need to update. What we need to do is every time we create a hot module is keep a reference to that in memory. We can then use the data, which is going to have the file, grab the correct module, and then call handle update. To this end, I'm going to create a new variable called hot modules. It is going to be global, and there's only going to be one. We can just define it once like this. It is going to be a new map of modules. Just as a reminder, we're going to have a type here. The map is going to have a string, which is going to be a reference to the file. And then the second argument is going to be a hot module. We're then going to populate that every time we create a new hot module. So I can say window.hotmodules.set. First argument is going to be this URL. So I'm going to say url.pathname. And the second is going to be the actual module itself. This path name here has got that leading slash, and that's exactly going to match up to what I just implemented on the server, which is going to be inside of here. So we can use this file string to get a reference to our module, and then we can go ahead and call handle update, and everything should hopefully just work. Let me show you how to do that. Inside of here, we have access to data. I'm going to show you what this is doing right now, just to give you a better idea of what's going on. Just going to refresh the page for good measure and head over to child. And if we save this off and everything is working correctly, we are not going to get a console log, which means something is not working correctly. The problem here is we're not actually getting this message, which is a little strange. If this doesn't exist, we should be defining it. Let me just do a quick log inside of here and see if that is getting triggered. Yeah, it is. And I guess we're doing something incorrectly. For example, maybe we're not doing a log here. Let's go ahead and, this should be message, not data. Let's go ahead now and try one more time. If I head over to my child and now save this one off again, head back to the browser, we are still not getting a log, which is a little bit frustrating. I'm also not seeing an error, which is very bizarre. I think I need to restart my server. If I now head back to my child one more time and save it off, head back to the browser, we are getting that log. So that was the problem. See, we're getting all of this data here, and inside of data, we have the file type changed, and we have the file, which is source/child. So we know which file needs to be updated. All we need to do now is head back to our client and handle this. We've got the data, which is going to contain file. So I'm going to go ahead and grab that from my hot module map. Just to clarify that is working correctly, we're going to say hot modules and observe that all three of them are here. We can use this reference to get reference to the hot module. We can go ahead and simply say const mod is equal to window.hotmodules, and you can see where this is probably going. Let's go ahead and just say .get data.file. I'm not going to do a check for data.type, which is file changed, since there's only one type right now, but we could definitely extend this one later on. Assuming this does exist, we can go ahead and say handle accept, and with a bit of luck, this should be working. We're going to get a message every time the file is changed. We're going to grab the module, assuming it exists and we didn't make any mistakes, we're going to handle accept. Obviously in production, you need a lot more error checking and error handling here, but I'm happy with this just as a test for now. Head back to the browser and refresh the page. Now going to head over to my editor, and if everything worked correctly, this should hopefully actually work. If I save this off, we are getting hot module reload, which is really cool. You can see it says it's uploading it here, and that did indeed update. If we save it a bunch more times, that is working correctly. We head over to app and save this off. Of course, nothing is happening, and that's because there's no hot module API for app. We are still getting the message, it's just nothing is getting changed. Just to clarify, that is working correctly. As a bit of a sanity check, I'm doing a console log inside of here, and we're just going to say data.file. Head over here and try this one more time. If I head back to app, it's the wrong one. Save this off, we are getting the log, nothing happens. Head over to child, that's working as well. And because child implements hot module reload, that is going to give me the console log and update. So everything is now working correctly. Did cover a lot of content. I'm going to leave a link to the source code and the diagram, definitely worth checking out yourself. Before we finish up, I'm going to show you Vite's hot module reload API and show you how similar it is to the one we just built. So you can see here, this is how they define it. They've got a few extra things, but they have the critical accept, which is what we just built as well. Not only do they have it, it's identical to ours. They have the guard here, they have the accept callback with the new module, they have the check, and then they do the implementation down here. I'm going to continue building this thing and modeling it after Vite. If this is something you're interested in, you should definitely sign up for the updates. It gives me a lot of motivation to continue building this. Finally, if you see another part of this you're very interested in, I might try and cover that one next. We've now got HMR, or at least a very basic version of it. I think the next thing we need is probably going to be a module map, so we can do things like bundling and do more advanced HMR use cases as well. But we'll see how we go. That does bring us to the end of this one, and I will see you in the next video.